For question 4, we need to find the period of this cosine curve. Now, the basic cosine curve, y equals cos x, has got a period of 2 pi, or 360 degrees. But we also find that the coefficient of x changes the period because it stretches it or dilates it horizontally. So a little recipe that we have to find the period of any sine or cosine curve is to say, look at the coefficient of x, and the period will be 2 pi over whatever that number is. So in this case, we've got 3x here, so it's 2 pi over 3. Now, this works for the sine and the cosine curves. If you're working with the tan curve, then the period is just pi on n, not 2 pi on n. And that makes sense because we know that the tan curve is actually only half as wide before it repeats. Now, while we're on this question, let's have a look at a much harder question that could have been asked. What is the phase shift or the left-right translation of this curve compared with this one? Now, the number that jumps out is this pi on 2, and a classic red herring answer that would be wrong would be that it's moved pi on 2 units to the right or to the left. Both would be wrong. And the reason is that to identify the phase shift, you've got to say, what has x been changed into in terms of x plus or minus something? And that means that you have to separate this x from the 3 that's with it. And you can do that very simply by factorising. This way you can see that the 3 is the number that's going to affect the period, and that will give it the period of 2 pi on 3. But after that, you can clearly see that this curve compared to this one has the x being replaced with x minus pi on 6. And that's going to move it to the right, pi on 6 units.